2.5, zeros of polynomials. You've been finding zeros of polynomials. I've told you that's where you're going. They just haven't told you to graph it yet.
Don't plan on either.
Okay, you know the nth degree polynomial can have at most n real zeros. We've talked about that. So if I have x to the fifth, the most real zeros they have are 5, right? Mm-hmm. So that means it could cross the graph at 5, it could cross the graph at 4, but it can't be 7 or 8, right? But according to the fundamental theorem of algebra, when we have complex numbers in there, every polynomial has exactly n zeros. Now I left out what word? Real. Every polynomial has n zeros. They aren't always all real, but they have, this polynomial, whatever it would be, would have 5 real zeros. Okay. Not real zeros, I put the word in there. 5 zeros. Okay. The fundamental theorem of algebra tells you that only that they are zeros, not that what they are, whether they're real or rational.
We have a test this week.
I know, that's why I said this is the last section. Okay, find all the zeros. So f of x equals x minus 2. How would I find those zeros? Set it equal to 0. So x equals 2. So the x-intercept is 2, 0. So these are zeros. And this is the x-intercept. Be careful which one I'm asking you for. If I'm asking you for a 0, you can write x equals. If I'm asking you for an x-intercept, it needs to be a point. People lose more points on that than anything else. Okay, what about the next one? F of x equals x cubed plus 4x. Set it equal to 0. And what?
Can you factor?
Yes, I can factor out an x. If that was a minus.
Square root.
Okay, if that was a minus, I'd say x plus 2, x minus 2, right? But it's not a minus, it's a plus. So at this point, we're just going to set it equal to 0 again, right? Mm-hmm. So I get x squared equals negative 4, and then take the square root. So x equals plus or minus
-2.
2. Oh, the square root of -4. Right? Because you can't.
Yeah, but what is the square root of negative 4? We can take that now.
Oh, didn't know.
2i.
2i.
Oh.
So I have 2i and 0. Yes? Now, we also could factor that if we remembered. We could factor it into x plus 2i and x minus 2i. I remember talking about that last week. But we probably wouldn't. We would just set it equal to 0 and solve it. So, this one up here, the degree is 1, so it says it has 1 0. Yes? And is it a real 0? Yes, it's 2. This is 3, so how many zeros does it have? 3. This has 3, but how many are real?
2. 1.
1. Because the other 2 are in the complex number system. Thank you. So if I were to graph this, it would cross here, but it would have some little, like a little thing like that or something. Okay. F of x equals x squared minus 6x plus 9. You would do what? Factor. So factors of 9 that add to 6. 3 and 3.
-3 and -3.
So x minus 3 squared. Now, guys, fix it. I don't want to see anybody on the test tell me this is x squared minus 9. I don't want to see it. You have to FOIL it. Okay, and so I get x equals 3. Well, this says I have 2 zeros. I only have 1 0, but this 0 has a multiplicity of 2. So do I have 2 real zeros?
Oh, yes.
Yes. So what?
X 2.
There's multiplicity of 2, because this is x minus 3 times x minus 3. So that means at 3 the graph
Oh.
bounces,
okay.
right?
I know what you're saying now.
Okay, so x to the 4th minus 1. Is that difference of squares? But instead of x, it's x squared, right?
Minus 1.
And then x squared minus 1. Can I continue to factor?
Yeah.
Well, this is x minus 1 and x plus 1. Yes? And then if I remember, this would be x plus I and x
Minus I.
minus I. So I get x equals plus or minus 1 and plus or minus I. How many zeros do I have? 4. How many are real? 2. So be careful on your test. I'm going to ask for all the zeros. I'm going to ask for all the real zeros. I'm going to ask for all the rational zeros.
Hang on. How did you get the I? You went really quick there.
X squared plus 1.
It's the x squared plus 1. So if I did x squared equals negative 1 square root, so x would equal plus or minus I.
Okay.
So I basically just move this back over to make my factors.
Okay, what about the x squared plus 1?
That's where it came from. This is this. So these would be
Oh,
those
okay,
factors.
Okay. That makes sense.
So you're going to have to read. Am I wanting zeros? And if I want factors, then I want what? That. Like on your quiz, it said do this to find the rest of the factors. I didn't want the zeros. I wanted all the factors. So you have to make sure you're answering what I'm asking.
That's making it more difficult.
I know, always.
Better not be that many words, because I'm bombing it.
Nothing over 2 letters.
Yeah.
Okay,
pretty much.
so rational zeros test. Rational zeros test rational numbers. Okay, first of all, we need to know what a rational number is. 1 a rational number?
Yes.
Yes. Is 3 a rational number?
Yeah.
Yes. Is the square root of 3 a rational number?
No.
No. Got it?
Okay.
Is 3i a rational number?
No.
No. Okay, so the rational zeros test only talks about rational zeros. Okay? Is 5/3 a rational number?
Yeah.
Yes.
You wrote 3/5.
Oh, it said 5/3. Either one. Are they a rational number? Yes. So what the rational zeros test states is the possible zeros of a polynomial. It does not do anything else. So what I call this are PRZs. What does PRZs stand for?
Rational.
Rational zeros. Okay? And we did this last year, so I don't know if you remember. Okay, you take the factors of the constant divided by the factors of the leading coefficient. So I would have ax to some n plus ... plus the constant. So the factors of the constant come up here, and the factors of a go down there. And it's all pluses and minuses of them. Now, this is possible. think of a number like, what number would have a lot of factors? What about 100? Would 100 have a lot of factors?
Yeah.
Yeah, but if we think about the factors of 100, it's still less than infinitely many that I would have to choose from, correct? So what this does is it gives me numbers to choose from. But again, the numbers I get are only going to be rational numbers. Are there irrational zeros? Yes. Are there imaginary zeros? Yes. So this is not going to give me all of the zeros. It's only going to give me the what? The possible what, though? Rational. Okay? Everyone got this written down?
Mhm.
You always start so late. You probably don't remember it yet, but once I write it down, you're going to be like,
Probably not.
I got the hiccups. Olive, can you put that down, please?
Yeah, sorry.
They're supposed to be in your bags or turned over or not distracting you.
Sorry.
And I feel that it is. I'm like, Emma, take off her watch, too. She's been staring at that a couple times.
So testing that I feel like but I already checked it when my mom takes it.
What if someone died and I had to check it?
Yeah, for real. My stepdad
They would
is
call
in
the school.
My stepdad is
Okay.
in the hospital dying right now.
Okay, so it says find the rational zeros. Oh my gosh. So I need the PRZs.
One.
So,
Label it PRZs.
hold your breath. Drink water. Hold your breath.
Okay, so factors of the constant divided by the factors of the leading coefficient. What is the constant? 6. So plus or minus, and the plus or minus goes with all of them, okay? I don't want to write it with everything, do you? No. So what are the factors of 6?
1 and
1.
6.
2, 3, 6.
Okay, so plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Over the factors of leading coefficient.
Oh,
What's the leading coefficient?
1.
1.
So it's just 1 and 1.
So plus or minus 1. So we know that if I do synthetic division and get a remainder of what, it is a 0. 0. So what do you want to start with?
So you have to,
Plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6?
1.
1. Okay.
Actually, there's no point doing that. 2.
Okay, 1 is really usually not the best place to start. I mean, it could be 1, but... Okay, so 2. So make sure there's no gaps. It's in the right order. So 1, negative 1, 1, negative 3, negative 6. Okay? And we're going with 2. Everyone good with that? Okay, so you do it, I do it. We'll see what we get. Okay, is 2 a factor?
Oh, yes.
Yes.
Whoa.
Mm-hmm.
I got 0.
Oh.
Unless I did it wrong.
I got.
Whoops.
I whipped up my making.
Whoops.
Okay. So we started at a 4th degree. We are now down to a what? 3rd degree. So if we can factor it by grouping, we can factor it, or we can keep going. Okay. Now, our constant is 3. Yes? Because this would be x cubed
Yeah.
plus x squared plus 3x plus 3.
Mm-hmm.
So now my constant is 3, and my leading coefficient is 1, so I can get rid of what? 6. So now what do you want to do? I bet we have to do a negative. Why do we have to be a negative?
Because the last number is positive.
Well, yeah, well, all of the numbers are positive, and in order to get down to 0, I'm going to have a negative in there somewhere, right?
-1.
-1? Alex is good at guessing today.
I'm smart.
Now, there are educated guesses, and there are I'm grasping for straws, okay? Think about what you're doing. Sometimes it's going to be a fraction. Sometimes. But are we going to try the fractions first? Probably not. Okay, so now we're down to x squared plus 3, correct? Okay, so I can factor, quadratic formula, set this equal to 0. Those are my options. I should always be able to take care of a squared, yes? Now, could I continue to use synthetic division? Yes, I could. But probably not going to be beneficial to me here. Because they're both positive, and what am I going to have to do with that 3? Subtract it over. So is that going to be a rational 0? No. Because it's going to be imaginary, isn't it?
Yeah.
So it's plus or minus the square root of 3i. So is this rational?
No.
So not rational. So the rational zeros are what? X equals -1 and 2. So anything with the square root or imaginary is not going to be rational, is it? But again, read the instructions. Does it want all? Does it want rational? Sometimes it wants all and then the rational. Do you have to find all of them in order to find the rational? Yes. Except for I knew this was irrational. Hopefully by the time you're done, you'll know it is without doing the work. If you have x squared plus anything, when you subtract it over, it's going to be imaginary, isn't it? Unless it's a negative x squared. Questions?
No.
You guys remember doing this last year now?
No.
Yeah. Barely.
Barely. Oh, there's the graph. If I were to graph it, -1 and 2. See, it has how it has this little spot down here that's not exactly a parabola. That's where that square root of 3i comes in, plus or minus square root of 3i. Okay, so find the rational zeros. So I'm going to list PRZs. Every time, list your PRZs. What's my numerator? Plus or minus. Okay, if you guys have a problem, I'm going to have to show you. If on the computer, when you have this problem, you're going to have to write it differently than we do here. Okay, what'd you say? 1?
1 and 3.
1 and 3. Okay, what about the denominator?
2,
1 and 2. Okay, so this is how I would accept this. On the computer, you would have plus or minus 1, comma, plus or minus 3, comma, plus or minus 3 halves.
What?
Where'd the 3 halves come from?
The 2 under.
Right there, correct? So on the computer, when you list it, it has to be a list like that. I think you only have like one problem like that, maybe. Okay. So, any holes I gotta fill?
No.
No. So 2, 3, -8, 3. What do we want to divide by?
2.
2? I'm not even going to finish. Okay, 2's not going the right way, right? So instead of erasing it, I come back and make it a -2. Because if I did 2, I might as well try negative 2 next. Bless you. So then that would be negative 4, negative 1, 2, negative 6, 12. So is that going to work for me either? No? Okay, so... Hey, wait, why did you even tell me 2? And I forgot another one. Yeah, but we have plus or minus 1, plus or minus 3. I did forget plus or minus 1/2. And plus or minus 3/2. Do I have 2 at all in there? No. So is 2 ever going to work? No. I didn't even pay attention when you
Waste my
said 2.
time. Thanks a lot.
Okay, so now what would you like to try?
That's my number. 3.
3?
I don't know, Alex.
And
I want a half.
I'm gonna stop.
I want a half.
You want a half?
Yeah.
Do we want to try negative 3 since we're halfway there?
No, we don't.
No?
Yes,
I'm gonna
I
try it.
think so.
Do you have any toothpicks? Stuck them on the bottom of the road. Thank you.
Okay. So then that would be 9, right? So that'd be 1. Hey, aren't you glad I said?
What did I say?
You said positive 3.
You're like, I'm just gonna stop here.
I was, because that was with 3. Why was I stopping with the 3, guys? Like positive 3. Why was I not going to keep going?
Because the positive 3 would have gotten bigger.
Yeah, my numbers were going bigger. They weren't staying right around where they needed to. Okay, so I am down to x squared now. So I can look, we can try a half, or we could just factor.
What?
Because we'll have the factors of 2 that add to 3. Well, factors of 2 that add to 3 are what? It's 2 and 1. So let's just factor rather than trying to guesstimate, right? So 2x minus 1 and x minus 1. So setting those equal to 0, I get x equals 1/2. So 1/2 would have worked, Olive.
Oh, yeah.
And 1 would have worked, and we have negative 3. So negative 3, 1/2, and 1. So what that tells me is they're all rational. The 3 that I have are all rational, correct?
Mm-hmm.
It's an odd, and it's positive, so it ends up, so it started where? Down.
So 3/2 would have worked?
3/2 would not have worked. So negative 3, 1/2, and 1. Okay, and to figure out how far it goes up and how far it goes down, that's calculus's job. We're worried about the shape, the end behavior, and the zeros.
Okie dokie.
You can never explain how far it goes up.
Yeah, you do. Next year.
Right.
You actually?
Okay,
Not have to.
I'm gonna. Okay, we're gonna do the PRZs here, but then I think you guys have the hang of it. I want to do the PRZs here. What are they?
1, 3, 4. No, 1, 2, 3, 4, 6, 12.
Why are you so good about it? Wait. How do
I'll
you
just
get
go in
those?
order.
Factors of 12.
Oh, that's it?
Mm-hmm.
Yeah. Okay, cool.
And what's on the bottom?
1, 2, 5, 10.
Okay, so again, if I'm listing this, I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Yes? But then I also have plus or minus 3/2,
Ew.
plus or minus 3/5, but I have 2/5, and I have 4/5, and I have 6/5, and I have 12/5. Yes. And I have 3/10.
That's disgusting.
Oh, I forgot I had 1/5. I have 1/10. I would have 2/10, which would be 1/5. I'd have 4/10, which would be 2/3. Which do I have 2/3 already?
No.
No. Oh, 2/5. Sorry, it'd be 2/5, which I have already. I'd have 6/10, which would be 3/5, which I have already, and 6/12 would be, or 12/10 would be 6/5. Do I have that already? Yes. But you see how this list gets absolutely huge? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 30 different options. Because I have to plus and minus. So there's 30 different options. Now, am I going to start over here?
No.
Probably not. You might do 1/5. That wouldn't be too hard to do, would it? 1/5. 3/2 wouldn't be hard to do. But they're not where you're going to start. But it doesn't mean you won't have to use one. Okay? I want to look at this because I want to look at the directions. That's the only reason this is up here. Okay. So, the list of all possible rational zeros of f. Sketch the graph so that some of the possible zeros in part A can be disregarded. Then determine all real zeros of f. Okay, so list the PRZs. Have we been doing that? Okay. So plus or minus, what's the numerator?
1, 2, 4, 8, 16.
Okay. Denominator? 1 and 3. So I've got 1, 2, 4, 8, 16 pluses and minuses, and then I have 2/3, 4/3, 8/3, 16/3. Correct? Okay. Any holes in that?
No.
Okay, well then part B says sketch the graph so that some of the possible zeros in part A can be disregarded, and then determine all the real zeros. Okay, well, if I were to sketch the graph without doing anything, this is negative, yes? So it means I have to end down, so I have to start up. It's a 3rd degree, so at most I have how many? 3?
3.
So like -2, 2, and 4. How's that work?
Great.
So it would go, I don't know if that's what it looks like, but that's just what it told me, right?
Yeah.
Okay. And now I'm going to find it. So -3, 20, -36, 16. Again, I have no clue if that's what it looked like. -2, 2, and 4 were easy to graph. That was the only reason I picked them. Okay. What do you guys want to start at?
4.
Oh, look at that.
Look at me go.
You guys are really good guessers. Okay, if it didn't work, I'd go on, right? I do -4. Okay, so now I'm down to 2nd degree. Do you want to factor? Do you want to keep trying to go? We are down to 4 and 3, so I could get rid of these two, yes?
Yeah.
Are we on x squared?
Yes, because we were cubed.
We just factor.
Let's try 2.
You want to try 2 real quick?
Maybe -2. No. 2. 2. Yeah.
Okay. But you could have just factored again because it's squared. You can factor quadratic formula because it does say determine all real zeros. So like the square root of 3 is a real zero. It's not a rational number, right? But it is a real zero. Okay, so now I have x, so this is negative 3x plus 2. So x would equal 2/3.
Negative?
No, because I'd subtract 2, divide by negative 3.
Yeah.
So x equals 2/3, 2 and 4. So I was correct with 2 and 4. I guessed well. Didn't I?
I guess.
No, when I graphed it.
Yeah.
And so 2/3 would be like right here.
Yeah.
So it really looks like something more like that. So the whole point of finding the zeros is so you can sketch a graph. So this basically just puts everything you have been doing together. Are you good, Olive? Okay. The last thing we have to go over are conjugate pairs. Every time you see a plus bi as a factor, guess what is also a factor? A minus bi. Every time, if you started off with real coefficients, if there wasn't an I to start with, does that make sense? So if I say x minus 4i is a factor, what is also a factor? X plus 4i, because when I multiply that, I would get x squared minus 16i squared, which would make that x squared plus 16. That makes that sum of squares, not that difference of squares. Got me? If x minus the square root of 2 is a factor, what is also a factor? Plus square root of 2. Because that was found by x squared minus 2. So you went x squared equals 2 and then square root. So x equaled, got it? Every single time. Because you're going to end up with real coefficients, you're going to have that sum instead of that difference. Got me? Okay, what that is good for is it tells me find a fourth degree polynomial function with the real coefficients of 1, negative 1, negative 1, and 3i. So I have to go backwards, yes? Go backwards. These are zeros. Zeros came from factors because these are x equals negative 1, and 3i. So then if I add that back over, it's x plus 1. Add that back over, it is x plus 1, yes. Move this one back over through subtraction, it is x minus 3i. So what do I also know?
X
And then I'd multiply out. So this would be x squared plus 2x plus 1. And this would be x squared plus 9. I skipped because it'd be x squared minus 9i squared, which would make that a positive. And then I have to do what with these two things? Multiply them. So x to the fourth plus 9x squared plus 2x cubed plus 18x plus x squared plus 9. So x to the fourth plus 2x cubed plus 10x squared plus 18x plus 9. Okay, so we've gone from here to here. Now you have to go from top to bottom. Knowing that if I have positive 3i, I also have negative 3i.
Yes.
always have that conjugate pair. That only goes for irrational numbers, irrational zeros, and complex zeros, or imaginary. Whichever word you want to use.
Got it. Are we done?
I think maybe. I can't check because Olive's writing.
Sorry.
I would assume the next thing would just be an example.
Did you say Sadie Bogle?
It's a typical.
Oh, I thought you said Sadie Bogle. I was like, why did you use the government last names?
What?
Both of them.
Yeah,
Sadie Bogle.
I gotta be called Sadie, but not Sadie Bogle. Also, I heard you going, oh my, on the field
Okay,
last night.
okay, shh. Guys. Okay, so find all the find the polynomial function. So we're gonna go backwards again, yes? So I'll just set it up. What factor did 5 come from?
X minus 5.
X minus 5. Now this one's tricky because that was equal to X, yes? So we have to move both of them over.
So it'd be X
X minus 3 minus 2I.
and it'd be X plus 3.
Nope, it'd be X minus 3 plus
Oh,
2I. Where was the only sign change at? Between the, yeah, it was only on the imaginary part.
okay.
And then I have to multiply all that out. Should I have any I's left when I'm done? No. No, no, no. Does everyone get how that just happened?
Yes.
Olive, do you get how that just happened?
Not entirely. I'm not quite sure how I got from X. Like, I don't know why there's X minus 3.
Okay.
Minus 2I and then X minus 3 plus 2I.
Okay, so we move that, yes?
Uh-huh.
So we have to subtract the 3 and subtract the 2I.
Yes, I know that.
Okay, so I got this.
Right.
Now, for it to be a conjugate, the only thing that is changing is this sign right here.
Right.
So that's why it's minus 3 plus
So
2I.
only the ones with the I's have to have a conjugate?
Yes.
Okay.
Only the imaginary part has the, or rational, like square root. And then this one's the same thing. Can you guys tell me this one?
X plus 5, X plus 5.
Oop.
X minus 1.
So x plus 5,
X plus 5.
x plus 5.
X minus 1 minus 3I. X minus 1 plus 3I. Or square root of 3I, I guess.
Hopefully we have your notes for both days.